welcome to Monday's edition of Cracking the Cryptic, and today we've got a puzzle by the wonderful Joseph Namer for you. This is his ultimate mashup as well, that's what it's called, and apparently, well, the testing reports about this one are that it is a gorgeous puzzle. So we need to dust off our virtual pencils and prepare, I think, for incoming Sudoku delight. I'll read the rules in just a moment. Couple of things to mention first. If you're a patron of the channel, we've obviously got the sequel to DiMono's Everything Is Wrogn puzzle. Definitely have a look at that if you haven't had a look at it already. And either today or tomorrow, we'll release Mark's attempt at the Times Crossword Monthly Special, this brutally hard cryptic crossword, and that's a video I always enjoy watching, primarily because I like watching Mark suffer. As I think Oscar Wilde said once, there is nothing quite as funny as seeing your best friend fall off a roof. So that's what we've got over on Patreon. If you own our Thermo Sudoku app, make sure that's up to date, because that also has lots and lots of new puzzles there for you. And yeah, you should enjoy those. Now, what are the rules of Joseph's puzzle? Let me read them to you. There are quite a few today, quite a few rules, that is. We've got normal Sudoku rules apply. In cages, digits must sum to the small total in the top left corner of the cage, i.e. the uppermost then leftmost cell. So you can see it doesn't look like we're being given any cages in this puzzle, but that's because of the next section of the rules. Digits cannot repeat inside cages, and the cages themselves must be deduced. I love puzzles where I have to deduce my cages, so this already sounds exciting. The cage can have any shape, but the number of digits it contains must be equal to x, where x is the digit in the cell containing the total. So the killer cage total acts like an x sums clue, if you're familiar with x sums. So what I think this means is that, let's look at this square. So this contains a total. So if this contained a 3, that would be saying that the number of cells in the 11 cage, of which the 3 is a part, the number of cells in the cage altogether would be equal to 3. So if that was a 2, this would be a 2-cell cage. Let's pick a different number. A 39, so that could be a 6-cell cage, for example. But whatever size of cage it was would have to be in this square here. The square containing the killer Sudoku clue. Now, cages may not overlap. Clues outside the grid show the sum of all the digits that are inside killer cages in that row or column. Good grief. Right, so we've got clues outside the grid, and these are telling us that in this row, for example, cells inside the killer Sudoku cages, wherever they may be, sum to 17. So in this column, the killer cages sum to 22. Not the killer cages, the cells inside the killer cages sum to 22. And then the inequality sign means that row 3, column 4 is higher than row 4, column 4. Okay, well that is the simplest of rules to understand. Good Lord. Right, okay, so we've basically got to do sort of X. Oh, this is why it's called Ultimate Mashup, because we've got to make our killer cages using X sums, then use this stuff out of the grid, and it'll all, in the end, be okay. Well, hopefully. Do have a go to yourselves. The way to play is to click the link under the video. Now, I get to play. Let's get cracking. And I really have not got a clue how to start this. I think probably what makes most sense is to fill in the options for the sizes of these cages, because if they're all X sums clues in these, yeah, self-evidently this can't be a 4 or higher, for example, because if it is a 4 or higher, that's saying we have to make a total of 8 using 4 different digits, because we can't repeat a digit in a cage, and that's impossible, because the minimum you can make 4 cells add up to is 1 plus 2 plus 3 plus 4, which is 10. So this square has to be, it can't be a 1, because Here's a knowledge bomb from cracking the cryptic. 1 does not equal 8. So that is a 2 or a 3. Now, 15. You can't put a 2 here because you can't make the other cell a 13. 3 you can probably do. 4 you can probably do. 5 you can do, because you could have 1 plus 2 plus 3 plus 4 plus 5. So maybe 3 options for the 15 cage. The 11 cage could be 2, could be 3. Ah, that's interesting. Right, so this is something you learn from if you've done X sums puzzles before. You can't have an X sums clue of 11 starting with a 4, because although you can make 4 cells add up to 11, those 4 digits would have to very specifically be 1 plus 2 plus 3 plus 5. So the 4 couldn't be in the sum. So in fact, that square there can only be 2 or 3, I think. 12. 12 you can't do in 2 squares because 2 would have to go with 10. So 3, 4, you can't do 5 because the minimum 5 can add up to is 15. So we are narrowing these down. Oh, 44 is just 8 because of the secret. The secret we only impart to our favourite people is that if you add up all of the digits from 1 to 9 once each, you get 45. So this cage here can only be missing the 1. And if it's only missing a 1, it must contain 8 digits. So this is probably very interesting, because this cage, yeah, and look, I mean, obviously the cage total, remember, is in the uppermost cell and then the leftmost cell in that order. So it's not possible for this square to be part of the 44 cage, or this would be in a preferable position, if you like, to this square. So this cage is going to have to drop down here and then do something else. Oh, then it could turn left, actually. I'm not sure. Anyway, let's carry on with the X sums clues. 22. You can't start 22 with a 3 because the other squares would have to add up to 19. That's impossible in 2 cells. 4 is probably possible. 5 is possible, I think. 6 is not possible. And this is similar to, where was it, the 11 we looked at. The 6 isn't possible because although you can make 22 in 6 cells, it's an extension of the 15 logic. The only way of doing it is 1 plus 2 plus 3 plus 4 plus 5 plus 7, not 6. You can't have 6 in the total. So that's a 4 or a 5. 10 could be 2, 3 or 4, annoyingly, because 4 plus 3 plus 2 plus 1 equals 10. 39, the minimum you can make 39 from is 6. And there are a few ways to work that out. You can have done it just through practice in the past, but obviously the other way of thinking about it is what's the maximum number of cells that could be missing from a 39 total, given that all 9 digits add to 45. Well, if you miss out the 1, the 2 and the 3, that's the most you could miss out. That's 3 digits you're missing out, and that would give you a total of 39 for the cage. So 6, 7 and 8, I suppose. 8 would be possible if this cage didn't have a 6 in it. 15 we've already done. That's 3, 4 or 5 up here. Oh, nearly. So there's very nearly a triple in column 2. Now what do we do? Maybe we start colouring. That's always a good option, isn't it? So this 8 clue can never come to this square, because then this square would have been the uppermost leftmost cell in the cage. So this cage must come this way. 15 cage needs a different colour. We'll colour in some of these cages in different colours, shall we? Make that one orange. Do we carry on down to the bottom? The 9 total here is a little bit interesting. Look, I mean, So the minimum these two squares could add up to would be 6. So there's a maximum. Yeah, so there's either this is a 4-5 pair, or there is exactly one other cell in this whole row that's in the killer cage. Because what you can't do is say, you can't go 2, 5 or 2, 4 and then have another 2 in the row. So the only way of making 9, well, the simpler way of looking at it is you can't make 9 with 4 different digits. It's impossible because 4 different digits add up to 10 at least. So either only these two squares are in cages in the row, or there is exactly one other cell that is in a cage. Let's carry on. Let's carry on with colouring. Oh, people said they didn't like me doing black the other day, so I'll try and avoid that. Maybe I'll repeat purple on the basis this 8 cage can't get down here. 39 we can use blue for, and then we'll use orange might clash with that one depending on where this goes. Green we can use. This one won't reach all the way down to the bottom. So this 15 cage has got to come, it can never go up because then this would have been the uppermost cell in the 15 cage. So the 15 cage must just run along the bottom of the grid, however many cells is indicated by its X sums clue. So it's at least going to there. The 39 therefore must run parallel to it. And then it can drop down into row 9 as soon as this one finishes. Or it can carry on. Although maybe that might give us a problem with the 44 clue. Right, what do we do now? Not sure. I presume I have to use the clues outside the grid somehow, but other than the 9 here, I mean the 24 looks... Oh, the 12, look, the 12 has to... Yeah, the 12 can never take this square because that would be the uppermost leftmost cell if this was in the 12 cage. So the 12 cage comes here, must come here because it's at least 3 cells large. Row 2 maybe. Row 2 I've got a maximum of 9 in those two squares. If I make these 5 and 4, so I still need 8 more. So there's still got to be, that's interesting, there's still got to be 2 more cells in this row that are part of cages. Because I can't... Oh no, I can. Sorry, I think I've made it... I was thinking I couldn't put an 8 into this row in a single cell, but maybe I... 4, 5... Oh no, that's it. Oh, okay, sorry, I'm being really... Yeah, I'm not being very articulate or clever today. I'm going to just switch on my brain. Right, hopefully that's going to help. Because what I was thinking was, if these two squares have a maximum value of 9, and they do, then I was thinking, well, I would need 2 more squares in this row because I couldn't put an 8 in a single cell. But I was overlooking the fact that in theory the 15 cage here could contain an 8, but it can only contain an 8 if it starts with a 3 or perhaps a 4. Yeah, it can do with a 4 with 8, 1, 2 as its alternatives. But the point there is that if it doesn't have a 5 here, these two squares cannot add up to 9. So 5, 4 would force 2 more squares in this row for sure, because this would have to be a 5, and then the maximum digit you could put in this in any of the 15 cage would be a 5, because it would have to be a 1 plus 2 plus 3 plus 4 plus 5 cage. 4, 5. If this is not a 5, these would have a value of 7. I'd need 10 more, which obviously self-evidently needs at least 2 more cells. I'm not sure I'm thinking about this in the right way, though, because all of this is very interesting in the sense it's telling me that the 15 cage or the 8 cage has to occupy some space in row 2, but it's not telling me where they are. Maybe a better question is, can the 8 cage come down? Ah, yeah. Actually, that is a better question. Right, sorry. If the 8 cage comes down here, that really is interesting, because we know we need 2 more cells. We needed 2 more cells along with the whatever's in that cell and whatever's in this cell. We needed at least 2 more cells in row 2 to be in cages. Well, how on earth are we going to do that? The only way is if this 15 cage bends round like that. Now that must be disprovable. Yes, I can disprove that, because now look at box 1. Box 1 now has 6 cells in cages in it, and what would these digits be? Well, an 8 cage in 3 cells can only contain the digits 1, 2, 3, 4 or 5, and a 15 cage in 5 cells can only contain the digits 1, 2, 3, 4 and 5. So these 6 cells in box 1 all have to be selected from 1, 2, 3, 4 and 5. That's impossible. You will have to repeat one of them. So this doesn't work. And if this doesn't work, the 8 cage never drops down into row 2 of the grid, in which case it could still come here. So we still don't know what the 8 cage is in terms of its number. We just know it doesn't come there. Oh, but now... Hang on. So now the 17 total for row 2 is only generated by the 15 cage and the 12 cage. And the 12 cage can only contribute a 3 or a 4 to that total. So the 15 cage has got to be contributing either 14 or 13 to the total, and that means that the 15 cage can only contribute exactly 1 cell outside of row 2 of the grid. So there is exactly 1 cell from this 15 cage in row 3, because we know that there's the cell, or the total amount of this 15 cage is a 1, or it is cells summing to 1 or cells summing to 2. Well, each of those options is just a single cell. So what does that mean? Does that mean that square? Yeah, that means this square has to be green. Because if it's not, I can't take 2 more squares in row 2 without taking this square, which is impossible for the 15 cage. This is really intricate and very interesting. Now, we know that this is not sufficient. So do we have to take that one as well? Let me just double check the logic there. If this is 3, I need these to add up to 14. For these to add up to 14, if this was a 3, this would have to be an 8 or a 9, for example. It's still not getting to 14, so I need more digits in this row. So I must take that square as well. So these 3 are definitely in. This one is definitely not in. One of these three squares is green, but I don't know which one. And I know that the 15 is lending 1 or 2 only to the 21 total. Oh, bobbins, right. 17 plus 21, here is a knowledge bomb, is 38. 15 plus 12 plus 11 is 38. So the 11 cage can't take any cells below row 3, because if it does, you can't make 38. As if once the 8 cage, I see. Once the 8 cage can't go into row 2, the only cages in this puzzle that can possibly appear in row 2 and row 3 are this 15 cage, this 12 cage, and this 11 cage. The 44 cage can never come up here, because this would then be the uppermost leftmost cell in the 44 cage. That means the 11 cage needs all of its 11 to be in row 3 exactly. So that square's definitely red. This one might be red. The 12 cage can't come down into row 4 either. Got it. I've got it. This can't be a 4. That cannot be a 4, because look, now the 12 cage, what are those 3 digits? They're adding up to 8 without using a 4. That means these 3 squares are 1, 2 and 5 to complete our 12 cage. In fact, I'll make this blue to show you why this is problematic. Because now what's that square? That square is a red 3, and a red 3 has to come along this row because it can't drop down. Well, that means this square needs to simultaneously be blue and red, and that won't work. We cannot make overlapping cages in this puzzle. So we can, in fact, I think, get a digit here. And it's a hard-earned digit. That is a 3. That means that's not a 3. Now, what does that mean? These 2 squares now sum to 9, which means that they have lots of options. Oh, yeah, okay. So now the 15 cage needs to provide 14 in row 2 in order to get us up to 17. Which means that row 3, the digit that is in the 15 cage in row 3 is a 1, because there are 14 of its total in row 2. That means there's a 1 in one of those 3 squares by the power of logic. The 1 is not there because that's in an inequality sign and we can't put 0 in the grid. There is a 1 in one of those 2 squares. Oh, good grief. Right, this puzzle is really exceptionally clever. Now, can we make this square a 5? Well, the answer is no, and let me tell you why. Where are you going to put the 3 in this 15 cage if this is a 5? Because it's going to have a 3 in it, because a 15 cage in 5 cells is 1 plus 2 plus 3 plus 4 plus 5. There was a 3 in that total. Well, we're not putting the 3 along there because there's a 3 here. So the 3 is going to have to go in this row. But as soon as the 3 goes in this row, you can't make the 15 cage contribute 14 to row 2 because it's missing the 3. So there is no possibility of a 3 in the 15 cage. Therefore, that square is not a 5, that's a 4. Yeah, now these 2 squares have to sum up to 10 to provide the 14 we need, without being 3, 7, 4, 6, or 1, 9, because there is a 1 in the 15 cage. It's just in this row somewhere in a position that we don't know. So you can't have 1, 9. That means it's 2, 8. Ah, this is even... Look at now. How do you make the 8 cage work if this is a 3? What does this square have to be? If this is a 3, this square has to be a 1 or a 4. It can't be either. So that inequality sign is to shift this 1 back into box 1 and break the possibility of this square being a 1. That's really lovely. So this square's a 2. That's a 6. That's an 8, that's a 2, that's a 3, that means this square turns red. Those two squares add up to 8, they're not 1, 7, and they're not 3, 5, so this is a 2, 6 pair, and there's a 2 here. So that's, oh, whoopsie, I didn't mean to do that. Ah! This square's a 6, because it can't be a 2, that square's a 2. What did they have to add up to? 9. They're not 1. Ah, yeah, okay. These are not 1, 8. They're not 2, 7. They're not 3, 6. So these are 4 and 5. Three by Sudoku goes in there. 5 by Sudoku goes in here. These squares are 1, 7 and 9, and we are cooking with a little bit of highly flammable gas now. This square is an 8 just by the power of Sudoku. Ah, that inequality sign loses its potency now once we get an 8 in this square. 4, 5. 3, 2, 6. No, okay. What do we do now? Is it more Sudoku, or is it... Ah, look, 4s and 5s are a little bit interesting. We've got to put 4s and 5s in those squares. So there's definitely 4s and 5s in 2 of these 3 squares. 5s. Right. Now look. Column 3 has a 6 and an 8 in it, so this square has to be a 7 now. There's no 4 in this square. This is a... Oh, yeah, look. All of these little totals are getting affected by Sudoku. That's not got a 2 in it. This is a 4. That 4 fixes the 3. Ah, so that's... This is a 4 and a 3 now, so there is a 2 in this row to complete the 9 total. Right, that's useful, because now we know that the 22 cage can never take this square, because if it comes into this square, remember, the only square in this row that's in a cage now is a 2-digit, it's a cell that contains a 2. Well, this square cannot therefore be in this cage because it needs to be a 2, and there's a 2 is ruled out already. So this 22 cage drops down there. Okay. Three clue here. That could be a 2, look. So we don't know what happens to the 10 cage. 22. 22 in column 3. I've got 21. That means I must put a 1 in a cage in this column. Where does the 1 go? It can only go here. That is definitely in a cage. It cannot be any digit other than 1. So the whole of the rest of this column is not is not in a cage. That's not very surprising, actually, because I think the only well, I suppose, can that 44 reach across there? 1, 2, 3, 4. Hang on, 1, 2, 3, 4, 5, 6, 7. Oh, it could have done. The 4 cage now can't take this square. Right, the 15 cage now hasn't got a 3 here, because that would mean these 3 squares have to add to 15, but those 2 squares would only add up to 4, so you'd need to put 11 into that one. That doesn't work. That's a 5. That's a 4. This one's a 4 by Sudoku from these 4s. This square is a 9 by Sudoku. Oh, I need... Yeah, and the 15 cage needs to be completed with a 1. That can't be the 1, because I can't connect it to the 15 cage. So that's going to be the 1. That's going to be the 7. This square needs to turn green. These 3 squares are now known to be 2, 3 and 5. In some order. Let's put that in. I can see that one can't be 3. This is beautiful. It's just beautiful. How can this be a 2? If this is a 2, it needs axiomatically in row 6 to be in a cage, and it can't be. Because I can't connect it to this 22 cage. It can't be in the 10 cage, or this would be the where the 10 clue would appear. The 39 and the 15 would need to go up to it. That's impossible. No, I don't see how that can possibly be a 2. That's a 5, therefore. There's a 2-3 pair in the column. The 22 clue is 4 cells. So if the 22 clue goes down all the way to the bottom of column 1, these squares would add to 22. Those squares add to 15, which means we'd get 37. These would have to add up to 8. They couldn't. They'd have to be a 2-6 pair, which they can't be, because they couldn't be 1-7 or 3-5. So the 22 clue doesn't come to this square. Does that matter? Maybe that's a complete red herring, actually. Yeah, no, actually, why don't we use the secret instead? If I know those squares add up to 17, and I do, the grey squares in box 7 must add up to 22 minus 4, which is 18. So there are three grey squares in box 7, which add up to 18, plus the 4 squares here, of which this is not grey, because that would repeat the grey 4. That's so 17 and 18, 35. There are 2 squares in this box that add up to 10. They are not 1, 9. Oh, okay, they're not 1, 9, they're not 3, 7, and they're not 4, 6. So there is a 2 and an 8 in this box that are outside of the grey cage. And we know this square is one of those digits because the 22 cage can't reach that square. So this square is a 2 or an 8. The 15. The 15 is done. Once I got the 5 here, I could have filled it in. Those 3 squares have all got to be... in fact, we know what they are. They are 2, 3 and 4 to complete the 15 total in 5 cells. That's a 4 because it sees a 2 and a 3. This is a 3. This is a 2. Oh, good grief. that square's not 4 anymore. But this means this square is 8. Yes, lovely. Now this 2 up here has potency, because the 2 is in one of those squares, but we know the 2 is not in the grey square, because the squares in this box that are not in cages add up to 10, and they are 8 and 2. 2 is placed. That forces the grey square to turn. The grey square can't take the 4, so we complete the grey region. I do not know how long it must take to create puzzles like this, but my goodness me, it's so impressive and so enjoyable to solve. Now, come on, what does that mean? Now we've got... So now, now the 39 region has to keep coming over here. It's 7 cells at least. So it comes to there. Now it could drop down. Or it could, it could continue as well. 7. It's missing 2 cells that sum up to 6 though, isn't it? And yeah, right, lovely. It's missing 2 cells that sum to 6. And look, you can't put a 2 in this 39 cage. Because remember, wherever the 39 cage moves, it's taking some portion of these squares, all of which can't be 2s. So if it hasn't got a 2 in it, it's also not got a 4 in it. Ah, now that might be interesting. Look, 'cause 4s have to be in one of those squares. Fours are aligning in columns 8 and 9, look. So none of those 3 squares can be 4. None of these 3 squares can be 4. This can't be a 4 because of SUDOKU. There is a 4 in one of 2 places in column 7. Eight's in one of 2 places in box 3. 6 is in one of 2 places in box 3. Maybe I'm meant to do more SUDOKU. 2 is in one of 3 places in box 5. Now, still haven't figured out where the 2 goes in row 6. 10k. Oh, the 10 cage now can't come here, because if the 10 cage comes here, this square we know has to be a 2, and it can't be a 2. So the 10 cage must drop down and then turn that way. Oh, actually, could it come that way? Ah, hang on. I might have made a mistake there. So few of the cages seem to turn left. I assume this one couldn't turn left. Let's check. If it comes that... Oh, no, okay. It can't come that way just by simple arithmetic. If it does, this square has to be a 3. And it can't be a 3, because that would repeat the 3 in the cage and repeat the 3 in the box. And probably other things as well. So, that's not in the cage, so this is in the cage. And these 2 squares have got to add up to 7, and they are not... they're not 3, 4 or 2, 5. This is a 1, 6 pair. Oh, lovely. Right, got it. This is a 1, 6 pair. Now look at that. That must be 6. That must be 9. That must be 3. That's a 1, 6 pair. These squares are 7, 8, and 9, I think. Okay. So now, what are we doing next? So actually, I've really not done much thinking about this 8 cell 44 cage. I've got 24 in this column. That looks very open-ended at the moment. And I've got the 39 cage to think about. I've not got much else. So, how do I think about this? So the 44 cage hasn't got a 1 in it. Hang on. I've still not put the 2 in this row. That's probably the place we need to think urgently about. So that could be a 2. Yeah, in fact, where does the 2 go in this row? The 2 has to be in a cage. The only cage it can be in is the 44 cage. Every other cage either can't bend upwards, because this would then be the uppermost cell in the 39 cage, or has been used up already. So the 44 cage has a 2 in it in this row. That's a 7 by Sudoku. I just noticed that. Hang on. Let's come back to this, because that's actually important. Look, because now these squares are 5, 8, and 9 in the 39 cage. So this square now can only be a 1 or a 3, because we know we're only missing 2 and 4 from the 39 cage. So having placed 5, 7, 8 and 9, we need to place 1, 3 and 6 in it. This square cannot be 6. So this is 1, 3 or 6. Right, so this square here has to be in the 39 cage, because if it's not, how does the 39 cage get its complement of digits? It's going to have to take 2 more cells from row 9 of the grid. Well, these 2 cells, one of these squares would have to be a 1 or a 3, and neither can be. So this square is not in the 39 cage. Sorry, is in the 39 cage, therefore it's not a 4, because we know there is no 4 in the 39 cage. Good grief. Right, okay, that is in. So now we know one of these 2 squares is in the 39 cage, because this can't be, and one of these 2 squares is the 6 that we need. So one of those 2 squares is a 6. Therefore, one of those 2 squares is a 6. By Sudoku, just using these 6's and these 6's together. So none of those squares can be a 6, none of these squares can be a 6. This square, therefore, must be a 1 or a 3. And all of this was a bit of a sidetrack, because I was trying to think about where 2 went in this row. Now these squares now, look, have got to be 6, 7 and 9. Oh no, we don't know. 6, 7 and 9, that's not 6. These squares are 2, 5 and 8. We can do a little bit with that. Look, that can't be 8. That can't be 2. This 4 is giving us the 4 and the 5 up there by Sudoku. Sorry, I should do more Sudoku. That gives us a 2 here. 4s, 5s, 8s. Still haven't got the 2 in here. I'm finally going to concentrate on where the 2 goes in row 6. So it can go here. It can only go in one of 2 places. And we know it belongs to the orange 44 cage. It's something to do with the 24 clue. maybe we've got to ask how many cells in column 8 are in cages. This one obviously is, this one obviously is. That one we don't know about, but it could be. This one can't be, because it's to the left of this one. Yeah, there's something going on here, because, well, we know this square is definitely in the orange cage, because that one isn't. And what I'm trying to think about is, one of these two squares is an orange too. If it's this one, now the whole of the rest of this row is not orange. Does that make this 24 impossible? Or could you come down through there? Ah, that's maybe how you do it. Ah, no, you can't. Oh, this is very... Right, this is really clever. This is really clever. You can't do that. Hang on a minute. So if I can't get to there... I'm just having to think about this. If I can't get to there, the only... That's in 6, 9... No, it's not enough. Good grief. This is really complicated. But this cannot be a 2. Let me show you why. It's really clever. So, the question is, how do we fill the complement of the 24 clue now if we make this a 2? And the thing to realise is that if we make this a 2, it's not possible for this square to be orange anymore, because you can't track the orange region through this square to this square to this square. Remember that none of these squares can be orange, because we've already got our 9 quota used up in the row. So the only way that this square is orange now is if we can take all 3 of those squares, having come through this 2 clue. But 7, 5, 8, we'd be repeating the 8 in the region. So that doesn't work. You can never get to this square. So if this is a 2, this square is impossible. So which squares in this column are we going to make orange? We can make that one orange. This one's impossible because the 9 clues used up. This one's impossible, we've just shown. So we've got 1, 2, 3, 4 as a maximum. But if we come to take this square, these 2 squares together have a maximum value of 6, which is the cell we need to complete the 39 clue, and 3, so that's 9. 9 plus 4 is 13. We'd have to put 11 into this square, which won't work. So this is not the 2. And that is, I mean, that is really, really lovely. But I totally don't think it's easy. And if it's not 2, that's the 2. It's the only other place the 2 can go. And once that's 2, we can turn it orange. Now, what does that mean? The answer is that I don't know. So now I've got 6 in here. I need 18 more. That's still going to be very difficult to do. The maximum I can have down here is 9. So I need 9 more at least. So I either have to take both of those squares or just this one. That could probably be a 9. Let's think about that. Maybe that's the thing we need to do. Controversial, I know. But if... Right, so we need 18 more. Let's ask whether this can be orange. If it's orange, it can't be 8. This would have to be 5. So let's make that 5 and have a think. We've now got 11 here. We need 13 more. This is, and we've got 1 digit to play with here, and a maximum of 2 digits to play with here. So we need 13. So we need all 3 digits, because this, whether this is a 1 or a 3, 1 more digit won't get us to 13. So we need all 3 of these digits. That means we know this is a 6. So now we need those 2 squares to add up to 7. Oh, beautiful. Doesn't work. Doesn't work. Remember, this is a 6 in this hypothetical situation. Now, if this is a 1, that's a 6. The 6 clashes in the column. If it's a 3, you've got to put a 4 here. The 4 clashes in the column. So you never take this square. And if you never take that square, how on earth do you get to these digits in this column adding to 24? You do it. You need this square, and this. We need these 3 squares to add up to 18. They're the only 3 squares available. Everything else is ruled out. You can never have this square. You can never have this square. We've proved that. And the only way you can make these 3 squares add up to what we need. Remember, this is always a 6. This is always a 3. Therefore, that's a 9. You have to max them all out. And there we go. Now we've hopefully worked out what's what. So now, yeah, now that's a 6 by Sudoku. I'm just trying to think about what the 44 is going to do next, because it can't take any cells in row 6 of the grid. So all the other cells it's going to have to be from row 5. 1, 2, 3, 4. 4 more cells in row 5. It's got to take those squares axiomatically. And it can't repeat a 2 in it. So that square's now a 2. That gets a 2 here and a 3 here. Ah, we've got to put a 3 in the 44 cage. It's got to go there because it can't go here. That gives us a 3 and a 4. We've got to put a 4 in the 44 cage. Oh, that can be in one of 2 places. Okay, so let's check. This is now 1. This is an 8. Therefore, that's an 8. Get rid of some pencil marks. This column, look, needs 1s and 7s to finish it off. Don't know if we can do that simply, but I can't see how immediately. That square is no longer an 8. This square is no longer a 9. Oh, I know what we should do. We should do something sensible. We know exactly what's in these 4 squares, don't we? It's every digit that we haven't yet placed apart from a 1. And another way of thinking about that is we've got to put an 8 somewhere in row 5 of the grid. We know it can't repeat in the orange, so the only place it can go is here. And we've got to put a 1 in the row. We know the 1 can't be in the orange, so this is 1. That's a 6. Okay, that didn't do a dramatic amount for me, did it? Slightly surprisingly, maybe. Have I actually? Have I got all the regions now? I think I have. Sorry about this. Let me just try and spot whether there's a simple next step. Let's have a look along the orange region, I think, just to finish it off. We need 4, 5, 6, and 7. 4, 5, 6, and 7. Now I can see that can't be 4 or 5. That can't be 6 or 7. We don't know about that one. We don't really know about that one. 7, 1, 2. Oh, this column looks interesting actually. 5, 7, and 9. Ah, naked single. That can't be 5 or 9. That's a 7. That's lovely. That gets me those squares. Now I need a 5 to complete. Oh no, I don't like a 5 there. I had to put a 5 up here. I really don't like that. What have I done wrong there? Did I miscompute the column? Let me just go back. I don't trust that at all. 5, 7 and 9. On that basis I can't put a 5 in this column at all, and I've made a bad error. Did I get this 5 and 8 the wrong way round? I'm not sure, but I don't like the look of that at all. I'm going back. I'm so sure that that feels wrong. What did I do with that? I want to look at this 5 and 8. When I put that 5 in there, I don't like it. Oh no, I'm having to go back miles. If I think it's right, I can just press redo. I just want to look at this 5, 8. What did I do there? I think I put the 5 in to test it, didn't I? I did. I put the 5 in to test it and then didn't undo it. I am such a wally. Well, at least I spotted it. So what logic did we do? We figured out that this was the 2. I then had to consider, I then thought about whether this could be a 5 and part of the sum, and we concluded it couldn't be. So we then know that to get the 24 to work, we need this square in, this square in. We are then able to deduce that this square was a 9, this square was a 3, this square was a 6. That was the only way of doing it. That becomes a 1. The 44 cage now has the same logic as before. Those go into the thing. This can't, the 2 can't repeat. That's the same logic. I think it's going to all flow now in roughly the same way. We need an 8 in the row. We need a 1 in the row. That's a 6. That square's not a 6 anymore. And now what do we need to do? Now we need a 3 in this cage. That's got to go here by SUDOKU. That places a 4 up here. Now we need a 4 in one of those 2 squares. That square is not a 2. I wonder if we get a similar... Yeah, this square is still a 6 or a 7. So I'm tempted to ask what this square can be. This square, 1, 2, 3, 4, 5. Yeah, this square is a 6 or a 7 as well. There is a 6-7 pair in this box, which is resolved, is it, by this 6? That gives us a 6 here. That gives us a 7 here, gives us a 6 here. Okay. I still don't think... Now I've got a 1-5 pair, which is resolved in a much better way. 5 and 1. 5 in a much better looking place. 8. 8 goes in at the top. We need 1, 7 and 9 at the top as well. That becomes a 9. We've got a 1-7 pair here. Golly, I think I very nearly butchered this solve, but I did, I think, rescue it. 7s and 9s go into those squares. 1s and 9s into these squares. Oh, look, the inequality sign does work again. This 8 can't be next to a 9, so it must be next to a 1. That becomes a 9. This becomes a 1, this becomes a 6. This is not 9 anymore. That's not 8. Right, those squares, they must be 6 and something. 8. Yes, there's a 6 here, that's useful. 6 and 8 go in. 8 can only go here. 7 and 9 is fixed at the bottom by SUDOKU. These squares are 1, 7 and 9, so the 9 can only go in that position. This is a 7, this is a 1, this is a 7. These squares are 1, 4, 5, which means that's a 5, that's a 1, that's a 4. The 4 gets placed here. Let's have a look here at what do we need. We need a 7 into one of these squares, which has to go there. The 5 and the 9 are fixed. And if I haven't made another error, this should be a 5, and that looks lovely actually. There you go. I think this is right. It's another long video, but I have solved the puzzle, and I don't think that was too bad a solve apart from my ricket with the 5 and the 8 here. But I'm actually quite relieved that I got to sort that out. Let me know in the comments whether you enjoyed that as much as I did. It's a brilliant puzzle, and thanks very much to Joseph for sending that to us. It's another stunner. And thanks very much for watching, and we'll be back later with another edition of Cracking the Cryptic.